Good morning. It's a pleasure to be here. My name is Kenneth Young. I'm a professor in the Department of Geography and the Environment, University of Texas. And I've been given the challenge to talk about North and South American montane forests in the context of the objectives of the conference. My title is Dynamics, Biodiversity, and Ecosystem Services of, like I said, North and South American montane forests. So let me start with an introduction to the Andean forest, a long stretch of mountains that goes thousands of kilometers north to south. Huge amount of diversity because of that. There's especially high biological diversity in the tropical and subtropical latitudes. But it's a very narrow set of mountain ranges in many places, so that you have both dry and wet ecological zones relatively close together. So this makes for extremely high, not just alpha diversity, but beta diversity. There's lots of difference from place to place. The mountains are often dominated by elements that are Gondwanan, that is southern hemisphere conifers and other taxa that are endemic to the southern continents in the course of evolution. Rather different than North American montane forests, which are, of course, are temperate and also go a very long latitudinal stretch from Arctic areas where you have coniferous forests down to the tropics themselves. And along those mountain ranges, you have great diversity associated with the ecosystems as a whole. And here the drivers are somewhat different in that the role of fire is often of great importance and great concern in these forests. The model on the right there shows a textbook example of how people have studied forests in both the South American and North American context, and that is in reference to elevation, topography, and exposure to moisture conditions. So with those things together, the environmental gradients can help define the forest types you would expect to find in a given elevation and a given exposure to rainfall. Some of the most interesting things and perhaps could serve as focal areas for investigations that you are, as a group, are interested in would be ecotonal areas. So they could be tree lines, for instance, where places where forests stop and non-forest vegetation begins. The classic example shown here are altitudinal tree lines, which of course are really interesting in a global change context because they presumably are controlled to a great extent by global temperatures. But there's many other things that affect the timberline and tree line situations, including the role of humans and decisions that people have to make in terms of responding to potential change in the context of ecological restoration and assisted migration. So ecotones, not just altitudinal ones, are of great interest as a monitoring target. Another one that I'd like to mention, though, is fire. So the central photos here are taken near Fort Collins, Colorado, the Front Range of the Rocky Mountains in the United States, shows the after effects of a large fire. On the left is the kind of study that you might make of a forest like that, that maps out the forest severity in terms of where you had high mortality and low mortality, or even patches of forest that escape. So the forest you see on a recovered slope post-fire would be a forest then that has recovered from these disturbances, and a disturbance mosaic approach that evaluates the patches formed by disturbance, the kind of disturbance, how long recovery is. All of those would be crucial also for understanding not just biodiversity, but ecosystem services. And in fact, I would suggest that ecosystem services, if you're thinking in terms of locking up carbon out of the atmosphere, that early stage recovery of stand initiation and stem exclusion, those would be points in time of ecological succession, particularly valuable for thinking about the carbon cycle. These photos remind us that disturbances aren't just coming from fire, they may be interactive. So here's disturbances related to riparian movements, wind throw, the saturated soils you find in upper elevation meadows, and insect pests. So all of those are collectively cause ecological succession. the old growth stage shown on the far right there suggests that that might be an important conservation target in many places where you have trees of all different ages. So if you were trying to include the forest dynamic aspects in the kind of monitoring you're thinking about, I suggest thinking about recruitment, thinking about tree growth, thinking about tree mortality as crucial measures of how the ecosystem and biodiversity follow the dynamics of forest in these areas. And in fact, you can summarize that in terms of these top-down drivers. So I've mentioned climate and weather, so that would connect to your concerns about global climate change, but also very intimately related are human land use and land management decisions. It's really hard to imagine me to explain conditions in Andean forests where I work in Peru without including the human roles as a top-down driver of change. So those would give a potential for understanding forest change and perhaps for thinking about a management, restoration, assisted migration in those contexts in terms of the top-down drivers. But the bottom-up drivers are also shown on this illustration, and those are topography and vegetation. So the things I mentioned that just define the potential types of forests, topography, elevation, precipitation, those allow you then to understand the potential vegetation and ecosystems you would have in a particular place, to which then you can address the fire regime or the disturbance regime more broadly in that perspective shown there in the middle. Successional patterns are very closely related to biodiversity trends. So some kinds of early succession have unique species. Some kinds of old growth or equilibrium type forests have very different species associated with them. And so your goals of biodiversity conservation also depend upon understanding the dynamics of the forest as a whole. Here's an example more thinking about the Andean situation where you have a very marked difference from east to west. So the slopes that face out either to the wet Pacific areas or the places that are affected by winds from the Amazon give you very wet conditions. So the Chocó and the Amazon are places in the Andes where the level that you find the cloud bank at is extremely important and will change with global climate. Other considerations though are the human ones. So as you move across a humidity gradient and elevation gradient in the Andes, you often find people, agriculture, rangeland, and so on. All those then also need to be considered when you're thinking about dynamics of the forest and the kinds of biodiversity and ecosystem services concerns you might have. Coming back to the central theme of ecosystem services, this figure puts it right in the middle there, and you'll notice that up above ecosystem services is human well-being. So that connects directly to all the things that people care about that you might get from nature, and including fertile soils, carbon services, nutrients in general, pollination, perhaps products from the forest themselves. All those are part of sustainability, but they're maintained by the biodiversity and ecological processes that I've been mentioning. So the processes that give you forest dynamics and forest recovery are feeding into the ecosystem services and making possible a vision of sustainability that can utilize landscapes in ways that are economically beneficial, socially just, but also map onto the recovery potential of the forests that you're interested in. Here's a whole bunch of different schemes. Some of them are centered on the water cycle. Some of them are centered more on soil nutrients and carbon dynamics in a managed crop situation, and some are more integrative. All of these, I think, are useful approaches to thinking about ecosystem services and considering ways to bring in biodiversity concerns. So here you'd be thinking about this more in a relationship of a gradient from, say, a protected area that you might have in a national park where the goals are to have functioning ecosystems on their own without a direct human intervention, all the way to highly managed situations that are used for livestock and for crops, and for producing, say, water that a nearby city might need. All those are very different ways of thinking about ecosystem services, and it would help to have sort of a conceptual framework for how to bring in the complexities of climate change and human land use. My suggestion is something like this. This is one I designed with Peruvian landscapes in mind. So there's public lands that are in those protected areas. There's communal lands nearby that are used by communities, often in traditional ways, that are at least presumably sustainable in the sense that they've existed a long time. There's demand by cities, companies, factories, farms, mines, and so on, also for resources that come from mountainous areas. All these are associated with governance institutions. So it might be that a possible approach to some of this complexity is not the scientific monitoring, but rather the social side of things and thinking about improving land use in ways that fits onto the ultimate goals of sustainability for each of the different land use types. In summary, then, things to think about: well, we're challenged by directional change, so global warming will continue to affect especially mountains, and it will force species upslope and into new assemblages, so we'll get novel ecosystems and novel species assemblages. So some of the things we've learned out of textbooks may or may not be true. It might be that some of the species in this transition will require assistance, that they will not be able to simply shift their distributions on their own, in which case there might be a need for thinking further about biodiversity concerns, and then again matching them onto the potential of the system for recovery, which then gives you the rates that you can use these vegetation for. The important contrasts there are between urban and rural areas is, of course, of great concern in North and South America in general. The montane forest, high mountain forest areas serve as important water resources, but they also serve as habitat for the wildlife we might care about. So all those things must be thought about when you're coming to overall solutions. And then as a final note, I would like to suggest that this conference is going to be really important in putting the forest, the páramos, the glaciers into a bigger context. So there's a number of these international programs here. I've illustrated the overall framework of the IPCC, well known to many of you, I'm sure. I would just point out that the forests in this slide are a very small part of the climate system that they're modeling and studying. So it's important to sort of bring the forest and the páramos and other living ecosystems of North and South America out into a broader profile, a higher profile rather, and look at the differences in biological diversity from place to place, that all important beta diversity that you find in mountains, where every part of the mountain is somewhat unique compared to another place in a mountain range, and how that complexity in place to place can be affected by and potentially shaped by the climate changes that are forthcoming. And then to bring in my land use idea again to finish up, there's a number of ways that governance could be used to better understand the use by people of these resources in ways that match the recovery potential of the forest. So forests that have always burned have a potential for recovery. That recovery rate can be studied in a disturbance regime approach, and that would give you valuable information on, say, the carbon cycle and nutrient cycles and water cycle as vegetation recovers, or perhaps as it colonizes new land exposed by successional dynamics up in the highest mountain peaks. All of these are challenges, but also opportunities. Thank you very much for letting me share a little bit of my ideas about the dynamism of forest in North and South America, and how that includes not only the potential negative effects of inappropriate land use and the challenges of climate change, but also the potential for finding solutions that are sustainable in the long term, not just because of the social dimensions that have been considered, but also because the ecological dimensions of recovery rates allow for long-term sustainable use. Thank you very much. It was a pleasure to share my thoughts with you, and I wish you the best in the conference. Thank you.